Have you ever wondered what makes up everything you see, touch, or even taste? Yes, those are atoms. Picture a world so minuscule that it's almost impossible to comprehend. This is the world of atoms. They are the fundamental units of matter, the basic building blocks that construct every little thing around us. From the air we breathe to the food we eat, from the chair you're sitting on to the screen you're looking at, it's all made of atoms. Atoms are so incredibly tiny, they boggle the mind. Imagine, if you will, the head of a pin. Now visualize that millions of atoms could fit on that pinhead. It's hard to grasp, right? These microscopic particles are the foundation of every substance in existence. They form everything we see, touch, taste, smell, and hear. Now, isn't it fascinating that such tiny things make up our entire universe? So what exactly is inside these tiny atoms that make up everything? Well, every atom, the basic unit of matter, is composed of three main components: protons, neutrons, and electrons. Picture an atom as a tiny city. The central part, or the downtown if you will, is known as the nucleus. This is where the protons and neutrons reside. Protons are the city's movers and shakers. They're positively charged, and they give the atom its identity. For example, an atom with one proton is hydrogen, while an atom with 6 protons is carbon. Neutrons, on the other hand, are the city's neutral parties. They have no charge but contribute to the atom's mass, along with protons. Now, beyond the nucleus, imagine a bustling cloud-like formation. This is where the electrons live. Electrons are the tiny, negatively charged particles that orbit the nucleus in this cloud. They're like the city's commuters, always moving around the nucleus, never staying in one place for too long. While the protons and neutrons are cozied up together in the nucleus, the electrons are buzzing around the outside. They're attracted to the proton's positive charge, but are kept in their orbits by the energy they possess. So, in our city analogy, the protons and neutrons are the city's infrastructure, while the electrons are the city's lifeblood, moving around and keeping things interesting. And it's these three components, protons, neutrons, and electrons, that make up the atoms that in turn make up everything we see and touch. From the air we breathe, the water we drink, to the screen you're looking at right now, it's all made up of these tiny, bustling cities of atoms. So, an atom is like a tiny solar system, with electrons orbiting the nucleus just like planets orbit the sun. Each atom, no matter how small, is a bustling, dynamic microcosm, mirroring the universe in its complexity and beauty. But all atoms are not the same, are they? That's where elements come into play. Indeed, the beauty of atoms lies in their variety. What makes one atom different from another is the number of protons it has. It's the protons that define the atom's identity, giving it a unique signature. For instance, an atom sporting a single proton is known as a hydrogen atom. Add another proton and voila, we have a helium atom. This is where the periodic table makes its grand entrance. This marvelous chart is not just a scientist's best friend, but a catalog of all known types of atoms, each categorized by the number of protons they possess. It's like an identity card for atoms, providing a snapshot of the incredible diversity that exists in the world of atoms. So, the variety of atoms results in the diversity of elements we see on the periodic table. Atoms may be tiny, but they pack a powerful punch. Ever heard of atomic energy? It's the energy that's stored inside an atom, in the very heart of it, the nucleus. This energy is so potent, we've found ways to harness it, most notably in nuclear power plants. These marvels of engineering split atoms to release the energy within, a process known as nuclear fission. But that's not all. When the nucleus of an atom changes, it can result in a phenomenon known as radioactive decay. The atom releases energy in the form of radiation, which can be harmful in large amounts, but has also been used beneficially in medical treatments and scientific research. Just imagine, these minuscule particles, invisible to the naked eye, hold within them such tremendous power. So atoms are not just building blocks, they are powerhouses too.